Hello friends, my name is Hitisha Kalawadiya. I am studying in class B.Sc second year at Adarsh College, Hingoli. Here I am explaining the problem of the theorem useful comparison integral. Let's see the problem of this theorem. Problem number 1. Test the convergence of integration of sin x by x dx between limit 0 to pi by 2. Sin x by x raised to p equal to sin x by x. 1 by x raised to p minus 1 is less than or equal to 1 by x raised to p minus 1. Proof: the function sin x by x is bounded and sin x by x is less than equal to 1. Therefore, sin x by x raised to p is less than or equal to 1 by x raised to p minus 1. Also, integration of 1 by x raised to p minus 1 between limit 0 to pi by 2 converges only if p minus 1 is less than 1 or p is less than 2. By comparison test, integration of sin x by x raised to p between limit 0 to pi by 2 converges for only p is less than 2 and diverges for p is greater than equal to 2. Remark: if f is positive, that is a neighborhood of then the integration of f of dx between limit a to b converges at a if for every a positive number n is less than 1 and a fixed positive number m such that f of x is less than equal to m by x minus a raised to n for every x in open interval a comma b. Also, integration of f of dx between limit a to b diverges if for every number n is greater than equal to 1 and a fixed positive number g such that f of x is greater than equal to g by x minus a in open interval a comma b. This is problem number 1. Let's see the problem number 2. Find the values of m and n for which the integration of e raised to minus x raised to n dx between limit 0 to 1. Proof: let k be a numbers greater than 1 e raised to minus x raised to n dx is less than equal to integration of 1 by integration of k 1 by x minus n dx between limit 0 to 1. K integration of dx by x raised to n between limit 0 to 1, since integration of 1 by x raised to n between limit 0 to 1 converges for minus n is less than 1 or n is greater than minus 1. Thus, integration of e raised to minus x raised to n between limit 0 to 1 converges only for n is greater than minus 1 irrespective of the values of m. So this is problem number 2. Thank you.